Hello everyone, so let's do another example. So in this example it says find dy dx for the equation below. And so here hopefully you can see that again we need to use implicit differentiation, right? So y is an implicit function of x, right? It's not as clear that y is a function of x until I try to solve for it. In this case I would not recommend trying to solve for it, right, because I have ln of y to the fourth, so y is like stuck inside of my natural log function there. And then also I have y squared on the other side of the equation. So there's a lot that's going on right there, so definitely use implicit differentiation. Okay, so my first step is to take the derivative with respect to x of both sides of the equation. So I have ln of x plus ln of y to the fourth equals d dx of y squared. Okay, so now looking at this, again I have the derivative of a function plus a function, so I'm just going to write that out, that I'm taking the derivative of the first function plus the derivative of the second function. Equals. Okay, and so now I'm trying to figure out what's the derivative with respect to x of y squared. And so again, hopefully you recognize, right, these variables do not match. And so I need to remember, though, that y is a function of x, right? So here I should be visualizing parentheses where I'm seeing the y there in our chain rule visualization. Okay, so visualize there the chain rule visualization that we've been doing for chain rule, right? So here I'm visualizing parentheses to the second power, right? So parentheses squared instead of y squared. So now I can remember I need to use chain rule. So just doing this off to the side just to show you what's happening here. So hopefully you guys would agree that in our parentheses to the second, like chain rule visualization, that the derivative would be this, right? So now if I'm trying to do the derivative d dx of y squared, I'm using that same idea where I'm bringing down the 2, copying the parentheses, in this case y, times the derivative of my parentheses, or in other words, times the derivative of y. Using Leibniz notation, that's dy dx. So I have that this is 2y times dy dx. Okay, so hopefully you see this, right? That I'm, again, my parentheses is my y. Okay, and then parentheses tick mark, that's telling me to take the derivative of y, so that's where I'm getting dy dx from, next to the y there that I just highlighted. Okay. So now on the left side here, d dx of ln of x, right? So this is just the plain old 1 over x. And again, notice that these variables match. Okay, so when you're trying to take the derivative of ln of x with respect to the x variable, we know that's just the rule 1 over x. But now when we go over to figure out d dx of ln of y to the fourth, this is where we're like, okay, these variables do not match. I need to remember that y is a function of x. And so here I should be visualizing chain rule. Okay. So here what I want you to do is, because here you want to recognize first off that this is ln of parentheses, right? So this isn't ln of x or just ln of y. This is ln of y to the fourth. Okay, so when I'm doing this, this is going to be 1 over my parentheses y to the fourth times the derivative of my parentheses, so d dx of y to the fourth. Okay, so I am using chain rule for ln of parentheses, so I'm just kind of These are like my off to the side thoughts. This is my other off to the side thought that I just used there. I used the fact that like ln of parentheses, the derivative is 1 over the parentheses times the derivative of the parentheses, right? So that's what I just did there. I did 1 over y to the 4th times, and then I just used Leibniz notation, ddx of y to the 4th instead of the tick mark. Just because now, using Leibniz notation, I can see again that these variables do not match. And so what I need to do now to take the derivative of y to the 4th is to visualize parentheses to a power. Okay, in particular, the 4th power. So what is the derivative of parentheses to the 4th power? Well, bring down the 4, copy the parentheses to the 4 minus 1, so to the 3rd, times the derivative of the parentheses, right? So if I'm trying to figure out, sorry, I forgot to write this part down. Okay, so if I'm trying to figure out what ddx of y to the 4th is, that's just going to be bring down the 4, copy the parentheses, in this case y is my parentheses, to the 3rd power, times the derivative of y, which using Leibniz notation is dy dx. So now when I'm going to this next line, I'm copying everything down, except now I'm actually doing that computation. So this now becomes times 4y to the 3rd times dy dx. So now I actually figured out what this expression was, right? And then, again, still copying every other line down. Okay. Alright, so now I did officially differentiate everything with respect to x. Now this is another tricky part, like I was saying. Now we actually have to go about solving for dy dx. Now hopefully you can see this, guys. I'm going to highlight everything that has dy dx in it, like the term itself, in blue. So here this is a term, right? Because everything's just being multiplied together. Okay, so that I'm going to highlight in blue. And this I'm also going to highlight in blue because both of these terms have dy dx in it. Now in purple, I'm just going to highlight the 1 over x because that does not have dy dx in it. So now what I want to do is get all the terms with dy dx in it onto one side of the equation and all of the terms without it onto the other. So what I'm going to do is move this term on the left-hand side that has dy dx in it to the other side by subtraction. Okay, so I'm just going to subtract it from both sides. So I have 2y dy dx minus 1 over y to the 4th times 4y cubed times dy dx. Okay, so I just subtracted that term here. Okay. So now what I want to do in this case is I'm going to factor out dy dx from the right side of the equation. Okay. Because now I reached my goal where I have all the terms with dy dx on it onto one side. So again, just so you can see, this is my first term. This is my second, right? So I'm taking out a dy dx from both terms. So I'm factoring that out. Now, what I'm left with in the first term is 2y. Minus, copy the minus sign. And now what I'm left with in the second term is 1 over y to the 4th times 4y to the 3rd. Okay. And so now at this stage, you might have noticed that we can actually simplify this expression here. Right, we can simplify this expression because the y's can simplify, they can cancel. Okay, so what I can do then to simplify this is 1 over x is equal to dy dx of 2y minus, and so now this becomes 1 over y times 4, because these y cubes cancels, so I'm just left with 1 over y times 4 here. Okay. And so now if I want to finish this off, what I need to do is just divide both sides by 2y minus 1 over y times 4. So I need to divide 2y minus 1 over y times 4 from both sides. Okay, and so I have that dy dx is equal to 1 over x divided by 2y minus 1 over y times 4, which is 4 over y.